All right, this is from chapter 5.6. We'll work a few problems, the odd number problems 1, 3, and 5 from the Law of Cosines section of our Precalculus book. And in exercises 1 through 4, solve the triangle. Problem 1, we have this triangle, and we see we cannot use the law of sines because we don't have any sides opposite angles. And specifically, using the law of cosines, we're going to solve first for this side opposite our largest angle, angle B, and for that, we use this form of the law of cosines, which is b squared equals a squared plus c squared minus 2ac cosine angle B. And now we will plug in b squared. This is remarkably like the Pythagorean theorem, equals 13 squared plus 8 squared minus 2 times 13 times 8 times cosine. We have our angle, 131 degrees. And B is going to be equal to all this under a radical. So we put 13 squared plus 8 squared minus 2 times 13 times 8 times cosine 131 degrees. And we go to our calculator to do that. First we check to make sure. There we are. Here we are in document settings. I see that we are in radians. Well, we need to get degrees to have this thing work. So we tab over to change here. We go to degrees, and we're going to tab down to OK. Here we are now in degrees. Let's go get a calculator page, and we're going to take the radical. So you have 13 squared plus 8 squared minus 2 times 13 times 8 times the cosine of 131 degrees. Make sure all that looks right. It does. We get 19.2213. So we're going to write in 19.2213. And so now, to solve, we need to find the other angles. And to do that, I recommend taking the smallest angle first, because in this case it doesn't matter as long as we're sure that angle is less than 90 degrees. But just, we're going to say the sine of angle C over side C, which is 8, is equal to the sine of angle B. Well, angle B is going to be 131, so we'll say sine 131 degrees over side B, which is 19.2213. And solving for sine C, we have sine C is equal to 8 times sine 131 degrees all over 19.2213. And lastly, if we want to get the angle itself, we'll say C is equal to the inverse sine. Let's see, inverse sine of all this, 8 times sine 131 degrees all over 19.2213. So let's do that. We have sine. We're going to get a division bar here. Let's see. Just to remember what we have here, we're going to have 8 sine 131 degrees. So 8 times sine 131 degrees all over 19.2213, and there we have, looks like 18.3073 degrees. So 18.3073 degrees. And so that's going to be angle C. We'll say angle C equals that. That's one of our answers. We have side B. And the last thing we need to do is find angle A. So angle A is going to be equal to 180 degrees minus 131 degrees minus 18.3073 degrees. So angle A equal to 180 minus 131 minus 18.3073 degrees. So 30.6927 degrees. So there we have angles solved for side B, and using law of sines, angle C, and then just subtracting from 180 degrees, we found angle A. So that is the triangle solved in problem number 1. Let's go to problem 3. Solve the triangle. Well, here we just have sides, so we're going to have to use the law of cosines again. And to do this, we're going to use the version with the longest side solved. To do that, we're going to take this version here, which is going to be a squared equals b squared plus c squared minus 2bc cosine of angle A. So our angle A is the thing that we are trying to solve for to begin with, because we know everything else. So we have 27 squared, which is at side A squared equals b squared, and b squared is 19 squared, plus c squared, which is 24 squared, minus 2 times 19 times 24 times cosine angle A. So we're going to solve for cosine A by subtracting the 19 and squared and 24 squared from both sides of the equation. So minus 19 squared minus 24 squared. We do the same thing on the other side. 19 squared minus 24 squared. We have cancellation here. So we have 27 squared minus 19 squared minus 24 squared equals negative 2 times 19 times 24 times cosine angle A. Next, we're going to divide everything by negative 2 times 19 times 24. And so we have negative 2 times 19 times 24. And we have cancellation here. So we have cosine A is equal to 27 squared minus 19 squared minus 24 squared all over negative 2 times 19 times 24. That will give us the cosine of A, and A is going to be equal to the inverse cosine of all this stuff right here. 27 squared minus 19 squared minus 24 squared all over negative 2 times 19 times 24. So we go to our calculator, and we have, we're going to go to cosine, inverse cosine, and control. So we have 27 squared minus, I believe it is 19 squared minus 24 squared. And let me make sure that's right, looking at my drawing. Yeah, I think that's right. Divided by negative 2 times 19 times 24. And let's see what that is. We get 76.8165 degrees. 76.8165 degrees. Does that make sense? I think it does. One six five. 76.8165 degrees. So that's angle A. Next, we're going to try to find angle using law of sines. I guess we can find angle, really doesn't matter. We'll find angle B, which is going to be our smallest angle. So we have, using law of sines, sine of angle B over the side opposite would be 19 equals the sine of 76.8165 degrees all over the side opposite, which is going to be 27. And so sine B, sine of angle B, equals 19 times the sine of 76.8165 degrees all over 27. So B is going to be equal to the inverse sine of all this, which is going to be 19 times sine 76.8165 degrees all over 27. And so we go to our calculator. Let's see, we go to sine, inverse sine, control, and to remember what we have here, we have 19 times sine, 19 times sine of, try to remember what that was again, 76.8165 degrees, 76.8165, and what are we dividing by? We're dividing by 27, so divided by 27, and we'll get 43.248 degrees. 43.248 degrees. So that's that. And the last thing we have to do is find angle C. Well, angle C is going to be equal to 180 minus 76.8165 minus 43.248 degrees. And so angle C, we go to our calculator, and there it is, 180 minus 76.8165 degrees minus 43.248 degrees, and we have 55.9355 degrees. So here we have all of our angles solved. Angle C, the most recent solved. Angle B, which we solved using the law of sines. And our first angle that we solved, which was angle A, 76.8165 degrees. Okay, now we're going to go ahead to problem number 5. Exercises 5 through 8 solve the triangle. Here we do not have a drawing, so we will construct a drawing. We have angle A. Angle A is going to be 55 degrees. Now, I'm going to try to make this more or less accurate. I'm going to say that's about a 55 degree angle. And then side B is going to be 12 in length. And so we'll say this is side B here. And side C is 7. And so we'll just kind of join these up here. So that's going to be angle B and angle C. And we're going to first try to find this side A opposite angle A. And to do that, we'll use the form A squared equals B squared plus C squared minus 2BC cosine of angle A. And we're going to fill in the blanks here. A squared is equal to, well, B, let's see, B is 12, so this is 12 over here. 12 equals B. So we have 12 squared plus C squared, which is 7 squared, minus 2 times 12. Let me see. Times 12 times 7 times cosine of angle A, which is cosine of 55 degrees. And now to solve for A is going to be equal to, we put all this on top under a radical. We have 12 squared plus 7 squared minus 2 times 12 times 7 times cosine of 55 degrees. And here we go to our calculator. Okay. Okay, here we go. Control, radical. We have 12 squared plus 7 squared plus 7 squared minus 2 times 12 times 7 times the cosine of 55 degrees, and we get 9.83052. 9.83052. So that's going to be A. And we see if that makes sense. Yeah, between angle 55. Let's go ahead and try to find the other sides. It looks like, let's try to find angle C next. So we say, using law of sines, sine of angle C over side C, which is 7, is equal to sine of 55 degrees over side A, which is 9.83052. And then we have sine C is equal to 7, cross multiplying the 7, times sine 55 degrees over 9.83052. So C, I'm going to come up here, C is equal to inverse sine of 7 sine 55 degrees all over 9.83052. And we go to our calculator. We go to inverse sine of, I think that's 7 times the sine of 55 degrees. And I forgot to put that division first. Let's see if this works. We'll divide by, what was it? Opposite 55 degrees. It's going to be 9.83052, right? 9.83052. And enter. We get 17. 0.6576. And see, this really didn't work out because we got times 0.052. I don't know what happened there. Let's try that again. Inverse sine. This time I'm going to make this division bar. We have in the numerator 7 times sine of 55 degrees divided by 9.83052. Okay, 35.6824 degrees. That looks better. .6824 degrees. So that's going to be angle C. And lastly, we're looking for angle B. Well, angle B is going to be equal to 180 degrees minus 55 degrees minus 35.6824 degrees. And so we do that. 180 minus 55 minus 35.6824 degrees, and we get 89.3176 degrees. And 0.3176 degrees. That's going to be angle B. Should be our largest angle, which makes sense because we have that's the largest side, so the angle opposite the largest side is going to be the largest. So that'll be our angle B that we got by subtracting from 180. We have angle C, which we got using law of sines, and we had angle A. We needed to get this side A, 9.83052. Anyway, these three problems should give you a good idea of how to do all the problems in this set. I hope this has been helpful to you, and thank you for viewing. Bye.